So next we have Nick White, COO of Celestia. He's also graduated from Stanford. So that being said, let's welcome Nick to the stage.
Thanks, Kuhn. Hey, guys. How many of you have heard of modular blockchains before? Yeah. Nice. Nice. Okay, good. That's what we're going to be talking about today. I'll give them a little more time to pull up the slides. Looks like I have my slides. Basically, Tendermint was the most battle-tested consensus engine, and the Cosmos SDK enabled us to build a really minimal blockchain that had almost no execution, and ABCI++ allowed us to have special interaction between the app and the actual consensus, and that enabled us to do block construction with the erasure coding for DAS more efficiently. So that's why. But a lot of people think they were or people get confused about what building on Cosmos means, and we just use the Cosmos software stack. But that's a great question. Okay, let's back up a little bit. Yeah, so the title of my talk today is Modular Expansion and the Path to 1 Million Rollups. So I want to talk about what modular blockchains are, how the modular blockchain ecosystem is expanding, and what the end destination is. So, as Kuhn mentioned, I'm the COO of Celestia Labs, and since modular blockchains are still a relatively new topic, I'm going to start by just giving a background of where modular blockchains came from. And so first we have to start with monolithic blockchains. So the idea of blockchains started in 2008 when Satoshi published the Bitcoin white paper. And what was so novel about Bitcoin was that for the first time, you could implement a system that had rules without rulers. Now, in legacy systems of cooperation, if you want to have people all cooperate under a set of rules, you need someone in power, a ruler, to enforce those rules on everyone else. And the problem with that is that a ruler can corrupt the system and abuse it to their advantage. So what's so cool about blockchains is that they remove the need for power hierarchy in systems of cooperation, and you can have everyone enforce the rules on each other as equals, as peers. And the way that you do this is you have each of the users run a node of the system, and the node has a copy of the set of rules, and it's continuously auditing the blockchain and making sure that all the transactions are valid. None of them are breaking the rules that everyone agreed to. But the problem with this is that such a system is not scalable, because if you want to verify every single transaction, you have to download all the data behind every block and verify every single transaction one by one. And so if the amount of transaction data increases, that means the amount of data you have to download and the number of transactions you have to compute and verify also increases. And so eventually, if the blocks get too big, if there's too many transactions you're trying to process, you as the user, the participant in the system, can no longer actually continue to verify the chain. And so what this means is that monolithic blockchains inherently have a finite fixed block size. And then once that block size is all consumed, the supply can increase even if demand increases. And so the fees have to go up and the blockchain becomes less usable as a result. And this is what's led to sort of the age-old debate about sort of block sizes. Essentially, you can choose between having small blocks with high fees, but preserve decentralization because everyone will still be able to verify the chain, or you can increase the block size, which will give you lower fees and make the blockchain more usable, but then you end up losing decentralization because users get priced out of the ability to verify the network. And this is what led to, for example, the Bitcoin Cash fork, was this fundamental debate between should we increase the block size or should we keep it the same? And so, and the second sort of chapter, I would say, in the evolution of monolithic blockchains was when Vitalik published the Ethereum white paper. And what was so groundbreaking about this was that if Bitcoin is a calculator that has very limited functionality, Ethereum is like a computer where you can run arbitrary application logic. And so it blew the doors open on the kinds of things that you could build on top of a blockchain. And The only issue is that as a monolithic chain, Ethereum only supports one single VM. It's sort of like a computer that only supports one operating system. So sort of similar to the EVM, imagine if you had a computer that only ran Windows, but you're a developer who builds, you want to build a Mac app, or you want to build something in Linux. It just fundamentally cannot be supported on a chain like Ethereum that only supports the EVM. So even though it opened up the design space for decentralized applications, like a developer is still kind of like caged and constrained by the execution model that's supported by the chain. And this leads us to sort of the third chapter of this story, which is the dawn of this idea of modular blockchains. And this came around in 2019 when Mustafa Al-Bassam, one of the co-founders of Celestia, published the Lazy Ledger white paper. And in that paper, he re-envisioned what blockchains could be, how they could be designed and implemented. And essentially his idea was that you could actually take the functions of a blockchain that are coupled up in a monolithic system and then actually uncouple them and decompose them into separate protocols that are each specialized for that specific function. And then you can layer those protocols on top of each other and build applications from that. And you get some really cool advantages. So first of all, in a monolithic system where you have to download all the data and you have to verify every single transaction one by one, in a modular system, if you want to verify the chain, you don't have to do as much work. And the amount of work you do does not have to scale with the amount of transactions that you process. So instead of downloading the entire block, you just sample, you take a tiny sample of the transaction data, and instead of verifying every single transaction one by one, you verify a proof that all those transactions are valid. And so in the old case with a monolithic blockchain, as the block size increases, all of a sudden your node is no longer able to keep up with the network. But in a modular setup, even as the transaction data increases, you as the user are still able to verify everything that's happening. And the only constraint is that in order to make this secure, you need to have more so-called light nodes in the network to make it so that it's safe to increase the block size. But if you have users that run light nodes in their wallets, on their phones, in their browsers, then you get this effect where even as the demand for block space increases, the amount of block space you can provide can increase as well. And so you end up being able to have a flexible amount of block space, elastic block space. And so even if there's more demand, the fees of the network can stay relatively stable. And so instead of having to worry about having big blocks, small blocks, basically you can have the best of both worlds. You can have big blocks with low fees while still remaining decentralized and verifiable. And then the next superpower of modular blockchains is that because you decouple execution from the DA and consensus layer, you have the ability to define whatever kind of execution environment you want to run. So you're not limited to the EVM, you're not limited to anything actually. You can run SVM, you can run MoveVM, Cosmos SDK apps, literally any kind of execution. It could be a totally custom execution model. It's totally up to you as a developer to define that for yourself. And so it's sort of like, rather than be stuck in Windows, you have optionality between Mac and Linux and a whole gamut of different execution models depending on your use case. And so where Bitcoin was a calculator and Ethereum is like a computer, Celestia is like a cloud computer. So what I mean by this is that in Web 2, cloud infrastructure at its root has a data center that provides raw compute resources for developers to go and launch their own virtual machines that implement sort of like custom like logic for whatever web application they're building. And then in Web 3, the equivalent is a modular stack, where instead of having a data center, you have a data network like Celestia, and Celestia just provides raw block space upon which any developer can come and deploy their own custom virtual blockchain, which is a roll-up, and they can define custom execution, all tailor-made to whatever application that they're building. And so now that we covered the history of monolithic to modular blockchains, we have that background. I want to shift gears to the path to 1 million rollups. Now, you might probably be thinking that like, well, why 1 million rollups? It sounds kind of like an absurd number. It sounds very complicated and scary. And I mean, the way that I think about it is that where crypto is today is sort of like the very early days of the internet in the 80s, where there was maybe a few hundred servers, just like we only have a few hundred chains today. But if you fast forward to today's internet, we have over 200 million different websites and web applications that people use on a daily basis. And this kind of just massive scale of experimentation and utility has been enabled because it's so easy for people to build new websites and web apps. And I think if like that wasn't possible, then we wouldn't have the internet that we have today. That's been so useful and transformative for society. So modular blockchains, one of the goals is to enable the same thing. And I think that eventually, maybe 5-10 years from now, we're going to have a very diverse, rich network of different chains and applications. And it's all that experimentation that's going to yield net new use cases and enable like true mass adoption of Web3. And so luckily, that sounds really crazy. But fortunately, one of the superpowers of the modular stack is that no single team has to build all of it on their own. All the sub-problems are broken down into their own category, essentially, and there's multiple teams working to solve each one of the problems at that layer of the stack. And so it's a group effort. It's not, in a monolithic chain, it's one team who's sort of defining and making the choices and also having to basically build it all themselves. In a modular system, it's about cooperation. And specifically for Celestia, we're obviously very committed to making this whole vision a reality. And we launched our mainnet late last year. And since then, over 10 rollups have deployed on Celestia, including projects like Manta, which is the top, the third largest rollup by TVL, as well as Avo and Lyra, which together represent around 70% of DeFi options volume on Ethereum. And so the modular acceleration expansion is sort of happening as we speak. And part of what's powering it is the fact that Celestia is providing extremely cheap data availability costs. It drops the cost to operate your rollup and to use a rollup for users by about 100x. And so, for example, Manta, since launching about 2 months ago, has saved over $2 million in fees, and they've been able to pass that saving on to the users. And anyway, I want to talk a little bit more about just the high-level things that are necessary in order to actually enable a world, a future where a million rollups is actually possible. And I think this is just a very high-level sort of grouping of different categories of problems. But data availability is sort of the layer that provides the scale and throughput and security for the system. Execution is about basically where the applications live, making sure that those are verifiable, and there's a lot of optionality for developers. Sequencing is about basically being able to provide censorship resistance and liveness guarantees to rollups. And then we need interoperability, because if you have millions of rollups, they're going to need to be able to connect with each other. If they can't connect with each other securely or seamlessly, then we're going to have an internet the blockchain internet that is extremely fragmented. And it's about the internet, any kind of network. What makes it valuable is the connections between everything. And last but not least, we're going to need really robust infrastructure. People who, when you launch a blockchain, it's not just about whether the blockchain itself works. You need to make sure that you have a whole surrounding infrastructure of block explorers, indexers, RPCs, things like that, to make it really, really easy for developers to deploy a new chain. So I'll go quickly into each category slightly to talk about where we are and then what's coming and what we need to still build. As far as DA is concerned, we currently have Ethereum and Celestia. And Celestia has shipped DAS, which is a step function change in the verifiability and scalability of DA. But we still, frankly, have pretty small blocks by the grand scheme of things. There's no way that we would be able to support 1 million rollups on 2 megabyte or even 8 megabyte blocks that Celestia can support. And so we really need to scale that. But in parallel to that, if we were to scale DA throughput, we would also need to make sure that light node adoption also follows suit. So, and in parallel to that, we're working on Rust clients that will be really easy to embed in browsers and wallets and phones. And then the very, very end game, in order to be ultra secure, we need private DAS, which protects from selective disclosure attacks. And what's really exciting is that there are a lot of new DA protocols coming to market this year, like EIP 4844, which should launch any day now, and Avail and EigenDA. And so I think we're going to see a big expansion in the DA category. In terms of execution, it's a huge list, and I won't be able to go through all of it, but what I would say at a high level is that we have really robust support for EVM rollups. So we have all the EVM, sort of Ethereum L2 ecosystem building great tech, and so that's really, really well covered. But what we need, and we have one of the first Cosmos SDK rollup platforms, Dimension, that launched a few weeks ago. But what's still missing is actually more support for just general, all the different VMs that are out there. And we need more people to experiment with custom VMs that are sort of tailored to a specific application. And lastly, I would say that we need more robust and performant proof systems, because some of these rollups are just have multi-sig bridges, or the proving system is actually quite slow or expensive to operate. But I'm really excited about this category specifically because we have all these general purpose rollups launching, like Eclipse, Movement, and Initia and Fluent, which are bringing Solana, Move, and Wasm rollups to life. And we also have teams like Argus, which are launching the World Engine, which is a VM that's tailor-made specifically for gaming. And we're having, I think, a lot of insane progress in ZK VMs, both in terms of developer friendliness as well as the proving speed and costs. And so I'm really excited for Succinct and RISC0 and Valida. And in the interest of time, I'll move on. In sequencing, I also think this is really quite a pain point currently for the modular ecosystem, because most rollup frameworks only really support single sequencer mode. And I mean, some of them do have like exit mechanisms on the L1, which is really good. But overall, there's not really good safety and liveness guarantees, nor actually it's like just safety of the bridge guarantees with many rollups. And so I think I'm really excited by the fact that there's a ton of teams now working on shared sequencing that will make it so you can easily plug into a pre-existing network of sequencers that will provide all these like good guarantees of safety, of liveness and censorship resistance. And what's really cool too is that some of them are targeting not just decentralization of the sequencer set, but also giving superpowers to your rollup, like MEV protection or MEV capture, or things like atomic inclusion for cross rollup transactions. So there's going to be really cool innovation. A lot of teams like Astria, Espresso, Radius, and Fairblock are actively in testnet, and I think very close to launching. And then when it comes to interoperability, I also think this is quite a pain point for the current modular stack. The reality is that between rollups, it's primarily just committee-based bridging, and this is obviously not very secure. And what we need is we need to move to a model of trust minimized bridging. A lot of that is dependent on like better proof systems for rollups, which we are still kind of in progress of moving towards. And we also need to make sure that the user experience for people interacting with modular sort of rollups is seamless. And so I'm really excited about the work that's happening with account abstraction that enables you to have sort of like a unified account across many different chains at the same time. And also teams like Skip and Leap Wallet, who are building APIs and SDKs that make it really easy to sort of like route or like create transactions that route across multiple chains. So as a user, you don't have to worry about doing all these different hops yourself. Oh, and last but not least, I'm really excited about actually aggregation layers and proof aggregation as sort of the end game for interoperability. And last but not least is infrastructure. So in this category, there's been a sort of explosion of rollup as a service providers. And there's too many for me to actually name. But I would say the good thing is that the support for EVM-based rollups is really robust. But frankly, where we can improve is expanding support for more frameworks and actually more VMs as they come online. And eventually, also, a lot of these rollup as a service providers are still sort of like hands-on. But what we want to move towards is a fully self-service type of ecosystem where you could come to the platform and just click without interacting with anyone, click and deploy a custom rollup of your design, similar to what we have in like cloud providers like AWS today. And that even though I went through that long list of all these ingredients that we need to have for a world with 1 million rollups in it, there was one key ingredient that I left out, and that ingredient is actually the rollups themselves and the rollup developers. If we, as the modular ecosystem, modular infrastructure ecosystem, build all these components, but then no one comes to use them, then what's the point? And so I think anyone who's out there who's a developer and is interested in trying this stuff out, I think there's a massive opportunity to push the edge and the envelope of what's possible to build in Web3 by tapping into all the unique superpowers that the modular stack can offer. And really, I think of it as sort of like a candy store for someone who loves to build decentralized systems, because there's just so many cool things that you can dream up and do. And so in light of that, I'm really excited to announce that we're going to be doing a modular hackathon. The first modular hackathon, we're calling it the Infinite Space Bazaar, and it'll kick off sometime in March, and it'll last around 45 days. And there's going to be bounties and rewards for all different kinds of, using all different kinds of tools, and we're involving a lot of modular ecosystem partners. So stay tuned for that, and if you're interested, come talk to me afterwards, and I'd love to hear if you're thinking about building something. And that's it. Thank you very much. I talk about modular blockchains a lot on Twitter, so feel free to follow me and DM me, and I'd love to chat more, especially if you want to build something. Thank you very much.
Thanks, Nick.